Welcome back to our second video in our D3 Scatterplot project. The first video, we looked at the design of the project, we talked a little bit about the data set that we're going to be using, and we looked at how D3 version 5 loads data using this new idea called promises. In this video, we're going to talk a little bit about scales and why we would need them and why we would want them. It's important to do that now because we will use them in both videos 3 and video 4. So we'll start by talking our way through scales and what they are, and we'll see how to build them in the D3 project. So what is a scale and what does it do? Well, remember in our design here, we have our SVG box here, and we're going to put in a couple of axes, an x-axis along the bottom horizontally and a y-axis vertically along the top. One of the things that we need to do is we need to take the raw data from our CSV file and we need to convert it into pixel coordinates so that we can draw circles appropriately on the SVG grid. So if we just think about the y-axis for a second, one of the things that we're going to do is we're going to be mapping people's age onto that y-axis. So I just looked in my data set and I actually saw the youngest and oldest person of parenthood in that data set. The youngest is 15.3, and in the 17th century, these kids should have been playing video games. I don't know what they were doing. Anyway, okay, 15.3 is the youngest parent we have, and 54.6 is the oldest in that particular range of dates. And what we need to do, of course, is we need to figure out where those ages should correlate or correspond or map to our y-axis. So obviously 54.6 is going to go way up somehow on the top. 15.3 is going to be way down on the bottom. Now, I probably don't want them extremely exactly on the top and exactly on the bottom. I might want a little space, I want a little padding there, but we're going to figure that out in a little bit. And obviously, if we split something in the middle, like if somebody's, say, 35 years old, that roughly splits the difference between 15 and 54. So when we map a person who's 35 years old onto that y-coordinate, they're going to want to be somewhere in the middle, right? Exactly. So what we're doing here is we're actually creating a correlation or a map from age to a certain pixel on the SVG coordinate system. That maps us, right? It's a map row function that takes us from age to a pixel location. And we know how functions work, right? In JavaScript and Python and other languages as well, in fact, even in math. We take some input, and in this case, that's going to be age. We do some weird, funky black box processing in the middle. That's maybe that blue arrow. And what we get out on the other side is something else, and it's going to be a pixel location on that axis. Now, in math terms, these have they have some math terms, actually. So the input is called the domain, and the output is called the range. And the reason that we're specifying those terms is not to teach you math, but because this is exactly how D3 thinks about these things. So in D3, when we create a scale, which is this function, which is this mapping or this correlation from one set to another set, we need to tell D3 what the domain of that scale is going to be, and we need to tell D3 what the range of that scale is going to be. Well, surprise, surprise, the same thing's going to happen down here on the x-axis. The x-axis is going to map years, and so in this particular data set, I just drew them out. The earliest year we have is 1600, and the latest year we have in that data set is 1624. So obviously the same thing, right? 1600 is going to map to something towards the left-hand side of that axis. 1624 is going to map somewhere to the right-hand side. The domain for this one is going to be my year, and the range, again, same thing. Pixels on an SVG coordinate system. If I take something like 1607, obviously that's going to go closer to 1600, so it's going to have to hang somehow on the left-hand side of that axis. So in the long run, how we're going to use this, we're going to use it both to build the axis, but we're also going to use it when we start to plot points, and that's going to be in the last video. So let's just imagine that I have this person here, a man aged 35, became a parent at age 35 in 1607. What we'll do is we'll take 1607 and we'll hand it to our scale function, and that will give us a coordinate on the SVG grid where we can plot on the x-axis. So his point will be somewhere on that dotted line. We'll do the same thing with his age. We'll plug 35 into the other scale for the y-axis, and we will get a coordinate grid point there. And so we'll have both x and y, and then we'll know where to draw our circle. Remember, for SVG circles, there are a couple of different parameters that we have to give to those circles. One is a CX parameter, right? Where is the center on the x-axis? And there's also a CY coordinate, the center on the y-axis. Now, D3 has tons of different kinds of scales. Here are some of them. This isn't even the whole collection. But the one that we're going to be using is called a linear scale, or scale linear here. And what that means is that both the domain and the range are continuous. And by that they mean that any number in there is really possible. So any age is possible, from whatever it was, 15.3 to 54.6. We could have somebody who's 39.4827643 years old. I didn't get that precise. I rounded them off a little bit. But when both the domain and the range are continuous, we call that a linear scale, and that's what we're going to be using right now. There's another one that's really popular called the square root scale, and this is really important because the areas of circles are not linear. You might remember that the equation for the area of a circle is pi r squared, so you square the radius. So anytime you see data visualizations that have circles on them, any data viz writer is going to be wearing, like, red flags are going to go up, and they'll be like, "Hey, are you accommodating the area of a circle properly?" So we use square root as a way to manage the areas of circles. And if you want to go back and look at that book, The Interactive Data Viz for the Web by Scott Murray, he actually has a nice conversation about how to work with circles and how to use the square root scale. There's a power scale. We might see that right now for exponential curves, like, I don't know the number of cases of COVID-19, for example, in any country. That's following an exponential curve. Logarithmic scales are kind of the opposite in some senses, related, but kind of opposite. And there are tons of these in the real world. The Richter scale for earthquakes is measured as a logarithmic scale. So an earthquake of size 5 is actually 10 times bigger than an earthquake of size 4 because it's a logarithmic scale. Measuring sound is the same way, or the decibel scale is a logarithmic scale as well. Quantized and quantile are often confused with each other, but once you get the hang of them, I'll give you an example here, might make more sense. A quantized scale puts continuous data into some defined buckets. I think a really good example of that would be a test score. So you get 85% on your test. That's a continuous data point, but you are getting a grade on that exam of A, B, C, D, or F, right? So maybe 85% correlates to a B, and that's a quantized scale. A quantile scale is similar, but you're calculating the size of your buckets based on equal size groups. A classic example of that is a course that's graded on the curve, right? So no matter what your low scores are, the lowest certain number of people in your course are going to fail simply because they're at the bottom, right? They have the lowest scores. And by the same token, even if the top score in the whole class is only, say, 20%, that might be the best score in the class, so they're going to get an A. So a quantile score, think of grading a class on the curve. That's a really good example of a quantile scale. Ordinal scales use buckets to buckets. And so we could maybe think of an example like converting months of the year to seasons, for example, right? So December, January, February might be the months that map to winter, right? And so you're taking 12 buckets of months of the year and you're converting those now to 4 buckets of seasons. The last one is a really, really, really useful, very sophisticated scale, a time scale for establishing timelines. If you've ever worked with dates in any kinds of projects, you know how notoriously tricky and difficult and sticky and messy they are. But scale time is great for establishing timelines because nothing in dates works on like base 10, right? So we've got 365 days in a year, which is broken down into 12 months, but not all the months have equal number of days. so if you're working with timelines at all, take the time. See what I did there? Take the time to learn those scales. That's going to help you out enormously. All right. One last point before we start to play a little bit. You'll remember from the work that we've done with SVG in the past that the SVG box is actually a coordinate grid. And we can't see that coordinate grid, but JavaScript knows where those things are. So it can find any pixel point in that coordinate grid. 0, 0 is the origin, X goes from left to right, and Y, if you remember, this isn't right. In fact, it looks like this. So X still goes from left to right, but Y goes from the top to the bottom. So 0, 0, the 0 on the Y coordinate is actually at the top of the SVG box, and ours, say, is 600 pixels big. So for us, the Y coordinate of 600 is actually at the bottom. So that's really important to remember because our scale, when we build it here in D3, is going to be flipped for the Y-axis. That sounds complicated, but it's surprisingly easy to do in D3. It's going to be fantastic. Let's do a little chalk talk here before we turn to coding up some scales. One of the pieces of information, two of the pieces of information that I'm going to need to know before I can actually build my scale are what are the maximum and minimum values of my data set. D3's got some really great functions for us, D3 max, D3 min, and as you can see here, they take two different parameters. The first parameter is the data set that we want to look at. That seems pretty obvious, but the second parameter is a callback function. It might not necessarily be obvious about why that would require a callback function, but remember, our data looks like this. Every row in that CSV file produces a little JSON object with 3 key value pairs. And unless I tell D3 max and D3 min which of those key value pairs to look at, it can't guess. So if I'm looking at ages and I want to know the max age and the minimum age, what I'll do is I will send dataset here to D3 max, and then as the callback function, I will send this. And remember, as I'm writing this in arrow syntax or arrow notation, what that says is that this tiny little function here receives data in a function called D. That's going to be one of those JSON objects. And what it should return is d.age. So it'll go into that little JSON object and find the age key value pair and return that value. And I want to do the same thing with min. So those callback functions are really, really, really important because we will have complex data and we just need to tell D3 max and D3 min which parts to look at. Otherwise, they can't read our mind, right? Okay. So that's going to be important when I build my scale. And this is actually how I build it in D3. So I am building a linear scale, that's scale linear with a capital L. And you'll notice that I send it two things. I send it a domain and I send it a range. Now you know why we were working on those terms. So we already know on my domain here on the left, which is age, we know what the biggest age is. It's going to be D3 max, blah, 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 a subcall to D3 max. Now, that's going to map onto the y-axis somewhere. So what we want to map that to is a pixel position in the SVG coordinate grid. So let's just arbitrarily take 50. That gives us 50 pixels of padding up at the top. Is that enough? I don't know. I don't know. We'll figure this out later. Similarly, we know how to find the min. It's D3 min, blah, 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 blah. And what does that map to on the y-axis? Well, that maps to a bigger value because the y-axis goes down. And so a minimum age will correspond to something like y equals 550. Remember, our SVG is about 600 pixels tall. So it's going to give us 50 pixels at the bottom and 50 pixels at the top. Is that enough? I don't know. We'll play with that here in just a minute. All right. So what we need to do then is we need to send to domain and range two arrays. The first, let's do it this way. So we need to send two arrays. So the domain is going to go from D3 min to D3 max. So the first element in that array is D3 min. The second element in that array is D3 max. That is going to correlate or map to the array in the range. And you can see from my arrows here, D3 min is going to map to the y value 550. And D3 max is going to correlate to the y value 50. Now, does D3 care that the domain is going from low numbers to high numbers, while the range is going from high numbers to low numbers? No, it doesn't care one bit. And so this is why building a scale is really, really useful for us. Once we get this set in D3, we don't have to remember that that y-axis is upside down, and we don't have to worry about how that correlates. So D3 is taking care of everything for us here, and this is just one of the many reasons why scales are so useful in D3. Right, let's do the same thing for the X scale, but we'll just fill it in slightly differently here. Obviously, my domain is a number of years here, from 1600 to 1624. My range is going to be a series of X coordinate pixels, and we remember that the X-axis goes from small numbers on the left to large numbers on the right. So, in this case, my low number for years is going to be D3 min, and that's going to correlate to X equals 50. So I can fill those in my array here. D3 min is going to correlate to range 50. And by the same token, the biggest number in my years is going to be D3 max, and that'll correlate to, say, X equals 550. And again, that's going to give us 50 pixels on either side. Is that enough? We'll see. So if I fill in those blanks too, D3 max now correlates to 550. In this case, the domain goes from small numbers to big numbers, and the range goes from small numbers to big numbers as well. But D3 doesn't care one way or the other. Now, short caveat before we get too far. In some of my data sets, I don't have the full range of years. So, just take an example here. This isn't true of this one, but take an example. Let's say that the smallest year I had in this data set was 1610. I'm not going to get a 1600 on here. So for now, I am going to build my scales like this. I am going to let D3 figure out the minimum year and the maximum year, and we'll build the scale accordingly. By the time we get to the end, if we want to make a different decision here and say hard code in that domain, we can make that decision a little bit later. And here's the code. So you'll notice what I've done in my scales section here of my library is that I have built two functions. One builds an X scale and one builds a Y scale. And you'll see all I'm doing is returning to the caller a D3 scale linear. And my domain is from min to max. My X scale looks at the year component, right? Just like we did in the slideshow there. And I've just hard coded in for right now this range from 50 to 550. You'll notice here that I'm using a variant of the range function, which is range round. Range round takes any fractions and rounds them up to whole numbers. Now, that's not perhaps strictly necessary here, but we don't really have things like a third of a pixel, right? So all of the pixels are whole numbers, and so I've just used range round. Will that matter? Probably nobody is ever going to notice that. The Y scale is doing exactly the same thing, but in the Y scale, obviously, I'm looking at age rather than years. And as we talked about just a moment ago, my range round goes exactly the other direction. So it goes from big to small. And again, that's because that y-axis is upside down. Now, where do I call those? Well, remember, I've attached an event handler to that select function. So every time I load a new data set, we drop here into load file, and that's where I've built my scales. So every single time I load a new data set, even if I've loaded it before, even if I've loaded it 1,000 times before, every time I load a new data set, I'm going to build new scales automatically. I have assigned those to variables called X scale and Y scale, and you'll also notice that I have made those global variables up here at the top. So when I build those, I'm pushing those scales into the global space so that they will be accessible elsewhere. Will I need them elsewhere? I will. Right. Now, I want to show you one more thing before we look at the website here. I have written some throwaway functions down here at the bottom. Now, I could have just cut the video and say to you magisterially, well, you see, I have determined that at 67 pixels is where, but nobody shows you how they tinker around with this stuff. So here's what I did. I wrote some functions, lnx and lny. It looks like, if you've done math, it's not natural log of x. It's just a line in the x. I can vary the x coordinates. So it's going to be a vertical line that is at a certain x coordinate. So I can call that function directly from the console log, and I can just tinker with some lines and find out where they go. Same with the lny. That's going to draw a horizontal line at some y position on the grid coordinate, so I can tinker with that too. So here's where we can see, is 50 a good number or not? We'll see in just a minute. I'm also testing my scales to see if I'm drawing circles properly. So down here I have a function called circ, and you'll see that that just takes two coordinates x and y. Now those aren't even coordinates. So the x maps to year, right? So I'm going to put some bogus data in here, like say 1607, and then I'm going to pretend somebody is, 42 years old, and that's the y coordinate. And so you'll see here in lines 114 and 115, I'm setting the cx coordinate by sending that year to the x scale, and I'm getting the y coordinate by sending the age to the y scale. So I can drop some fake circles onto my SVG container just to see if they're going in the right place. Now, these functions, I could leave them, but in the end, these are sort of scaffolding functions. These are functions that I'm using in order to help me build the thing. And if I want to take them down and delete them later, that's totally fine. I can do that as well. All right. So let's look. I'll reload my page here just to make sure that everything is happening properly. And I'm going to load a data set. So let's just do that 16 to 1624. You'll see that that shows up over here in my console log, right? And if I ask, what am I asking for? Global data set, and we'll just get the third option out of there. You can see that my data set is coming in properly, which is fantastic. Right, now let's tinker and play with some lines. So I'm going to do an x at 50. And that's where my axis would go if my border is 50 pixels wide. let's put one at y50. Oh, sorry, that's going to go y550 right at the bottom. So if I give myself 50 pixels of leeway, that's where my axes are going to go. I'm kind of not certain that that's enough data, right? If I did maybe lnx, I don't know, let's go 70 and see where that is. 70 might be a little better for me. I have a little extra leeway down there, and by the same token, lny at, oh, this is going to be, go 550 minus 2 is going to be 530. Math is hard. There we go. So maybe those inner lines are a little better. Maybe 70 is a good boundary for me. So what I'm going to do in my library is I'm going to build those up as global variables, how much space I need there. And then I'm going to replace those hard-coded values with some math. I'm going to do that in the long run. All right. Now, let's just play, for example, with our scale a little bit. So we know that x scale is taking a year and turning it into an x pixel coordinate. So I can actually call that right here. So if I call x scale and send it the year 1607, that's going to correspond to an x pixel value of 196. If I call my y scale and send an age, 15.3, let's send 42 as an age, the y scale is going to correspond to a y coordinate of 210 pixels down from the top. And so I can find out with my circles what that might be. What did I do? 1607, 42, right? That's where my circle is going to go. So I can do a circle. I've got several of them on here. Let's go. This is one I did earlier. 1624 and 53. That goes up in the upper corner up there, right? So I can start to play now with all kinds of these. So circle, what's my lower one? Yeah, 1616. I'm going to pull that one out here. You can tell I've experimented with this a little bit before. And that's going to go way down here. Now, obviously, if I move my axes, that isn't really exactly where that's going to go. But this is how I can play with this, and I might leave these functions in here so that I can start to play with all of my numbers just a little bit more. One last idea before we let this video go. Even though my x-axes will all be the same length in terms of the number of pixels, the domain of values is different. So, for example, in the top, dataset 1 is going to have a domain that extends 50 years. And the bottom dataset, dataset 3, will have a domain that extends only 15 years. So what I'm worried about is in those data sets, if I have some points that are exactly at 1550 or exactly at 1625, those points are going to plot exactly right on top of the y-axis. And I don't want that to happen. Now, I could clip those. If you want to see what that is, you can go look at this D3 book. But instead, I think I want to solve this problem a little differently. So what I would like to do is add some extra years into my domain. So at the top here, that's a 50-year span. If I add 5 to one end and maybe subtract 5 on the other, plus or minus 5 years, that seems reasonable. So I get 1545 to 1605, and that moves my y-axis over a little bit. And so any data points at 1550 will not be on top of the y-axis. I like that idea a lot. Well, let's take it to the bottom data set. Now I got a bigger problem because 5 years down there is a lot more. It's a full third of the entire x-axis. So what this tells me is that adding and subtracting 5 hard years is not the best solution. I think a better solution would be to go with percentages. So if I add 10% or subtract 10% from one side, you can see that this seems more equitable. In a 50-year span, I'm still adding and subtracting 5 years, But in a 15-year span, I'm only working with 1.5 years, and that gives me a much smaller bit of padding there. I think that is a really, really good solution. Now, on the right-hand side, we probably wouldn't ever need to notice this, and maybe in the long run, I might take that part away. But I am worried about things plotting on top of other axes. So this is a good example. I think I will do the same thing mathematically for the ages, so that the younger ages, like in that one data set as we saw, 15.3 years, I don't want that to plot right on top of the x-axis. So I think I'll add about 10% there as well. And some code. Here's the page as it lays out right now, and you can see that I've added some of those boundary lines. Now, in the final project, these won't show up. These, again, are those scaffolding lines that will just give me a little bit of hints about where I want to put things. You'll notice it's not quite centered in the box, but that's okay. On the left and the bottom, I'm going to add a little bit more space because that's where my axes and my axis labels are going to go. I've decided that on the top and the right, I'm just not going to leave much margin or padding out there because there's really not much for things to run into. I have added, I'll show you the code in just a second, I have added a little bit of domain futzing, but I'm only going to do that down in the bottom left corner where points, I just don't want them to lay on top of those axes. And the top right, I think that's going to be okay. So if I go look at some circles, in the particular data set that I've loaded, this is the circle that is on the top rightmost point. You'll see that it just sits right on that intersection. But again, those two lines will not be here because they're just borderlines for me to see where I'm going. But the one that I'm really most interested in is this one, which is down in the bottom left corner. So this is actually exactly at the year 1600, and this is the lowest age we have is 15.3. So you'll notice there's that extra 10% both on the x dimension and 10% on the y dimension that just keeps those dots off the axis. I'm pretty happy with that right now, but if I think that 10% is a little big, I can come back and I can modify that. All right, let's look at the library for just a second. I had some rough numbers, actually some hard-coded numbers down in the code, and those always make me nervous. I can't remember what I had for lunch yesterday, and so I'm pretty certain that I'm not going to remember what any of those hard-coded numbers are in a week or a month or 6 months when I come back to this project. So what I've done is at the top, I've added some constants, and as is my habit, I typically put constants into capital letters. So you'll see that I've put in my SVG boundaries here and just set up my left padding numbers, right, bottom, etc., etc. So on the left and bottom, it's going to be 75 pixels. On the right and the top, it's going to be 30 pixels. And if I scroll down to my scales, let's look at the Y scale for just a second, starting at line 83. You'll notice that I have SVG height minus bottom padding and then top padding. So I'm using those variables down here rather than hard-coded numbers. If I decide later that my paddings are all wrong, or if I want to adjust this somehow, I don't need to go back down into this function and start playing with raw numbers. I just change things up at the top and that'll be all right. You'll notice too that in both of my functions, what I'm doing here at line 84 and 85 is I'm calculating the maximum and minimum of the age. This is for the y-axis. And you'll see that I created a new variable here called scale padding, which is 10% of that span, like 0.1 times that span. And you'll notice at line 88, what I do is I take the minimum age, in this data set that was 15.3, and then I just subtract that scale padding. And that's what's going to give me a little extra room down in that bottom left corner. If you look at the the X scale at 74, I just wanted to show you another D3 function, which is called D3 extent. D3 extent calculates at the same time both the minimum and the maximum. So if you needed both, like we do here, D3 extent is a great way to do it. What you get back is an array. I have put that into a variable called span. Span 0, the 0th element is going to be the minimum, and the element at position 1, right, the 1th element in my joke, 0th, 1th, 2th, 3th, at the 1th element is going to be the maximum. And so I'm just using span 0 and span 1 there, and I'm getting exactly the same thing. Again, just range round, that's going to round up those numbers so that we don't have, 0.6423 of a pixel, something like that. All right, well, that wraps it up here for the the scale video. This got to be a little bit longer than I thought. In the next video, we will take a look at how to create the axes, and we of course need both X and Y scales in order to do that. Thanks.